Okay, so today we're talking about lesson 2.5, and your learning goal today is to be able to use an area model to find partial products and then connect those partial products, relate them to the standard algorithm. Okay, so let's talk a little bit about what this learning goal means. Use an area model. Have we learned about area models before? Yeah. And today we're going to use an area model to find partial products. Partial products is exactly what it sounds like. Partial means part of something. And what's a product?
The answer to a multiplication problem.
Yeah, so we're going to use an area model to find partial parts of the product, and then we're going to figure out how all that relates to the standard algorithm that you learned in 4th grade. Okay? Today we're going to start by solving this problem. 21 times 5. Go ahead and write that in your notebook. Now, we could think of 21 times 5 as 21 fives. Or we could think of it as 5 21s, right? Look at this tape diagram I've drawn here. I haven't finished it, but I started drawing it, and I put different sections with 5 in each one. Am I thinking about as 5 21s or 21 fives? Based on my tape diagram, what do you see? Arhan?
So there are 5s in the boxes, so I think it's 5 21.
Did I draw 5 boxes with 21 inside each box? No. How much did I put in each box? 5, right? So how many boxes do you think I have altogether? So I'm drawing 21 fives. Go ahead and draw yourself a tape diagram that has 21 fives. Now if I turn that diagram on its side, what is that dimension on this side here? What do I have here? Itai? 21 of the fives. And what's up here? 5. Good. Okay. So this is where your tape diagram can kind of become an area model. Okay. So if we look here, now is this the same thing that I had before? No. Now this drawing in blue is what I had for my tape diagram. Remember how I turned my tape diagram on its side? Now I'm drawing an area model. It looks a little different, but it's the same, right? I can have 5 on the top and 21 on the side. Is that true? But I decided to split my 21 into 2 parts, into a 20 and a 1. That makes it easier for me to find the area of these different sections. So how can I find the area of this top section here? I need to multiply the length times the width, which is 1 times 5. What is 1 times 5?
5.
Okay. Now I need to find the area of this section here, which is the length times width, which is 20 times 5. What's 2 times 5?
10.
10. And how many more factors of 10 do I have?
1.
So I need to add 1 0. These are the partial products, 5 and 100. Because are either of those numbers the entire product?
No.
Each of those are part of the product, so it's a partial product. Go ahead and draw this area model in your notebook. Now we know when we use the standard algorithm, we're going to multiply the 1s first. So what's 1 times 5? 5. Okay. Do you guys see how this partial product is right here? Okay. Now we're going to multiply the 10s place. We have 22 in the 10s, so that's 20 times 5. What's 20 times 5? 100. Do you guys see how this partial product is right here? Then we know when we use the standard algorithm, we just add the partial products. So 100 plus 5 is 105. That would be the same thing. In order to find the area for this entire rectangle, we would have to add the partial products of 100 plus 5 for a total of 105. Okay? So do you guys see how the area model, each part of the area model is part of the standard algorithm? Good. Now, if my area model has a 23 up here, what number goes on the side here? What's our other factor? 31. What would be a nice way to split up the factor of 31? Sonia? 1. Why is it a good idea to split 31 into 1 plus 30? Itai?
Because 1 times 23 is simple.
1 times 23 is simple. What about 30 times 23? Is that pretty simple too?
Yeah.
As long as we like ones, we like to multiply by 1 because that's really easy. We also like to multiply by multiples of 10, right? Because factors of 10 are easy for us to work with. So now let's figure it out. Let's find our partial products. How can I find the area of this top part? What do I need to multiply, Danielle? 1 times 23, which is 23. So that's a partial product. Okay, now to find the area of this bottom part, we need to multiply the length, which is 30, multiplied by the width, which is 23. Can we do 3 times 23 in our head? Okay. What is 3 times 23? 69. And how many factors of 10 do we have?
1.
So that means I need to add 1 0. So our partial products here are 23 and 690. Okay? How would I find the total area now that I know the partial products? What would I need to do? Alina?
690 plus 23.
Right, I have to add the partial products. So 23 plus 690. What does that equal? 713. Okay, now let's see how that could relate to the standard algorithm. Okay, so when we do our standard algorithm, of course, we first multiply the ones. So 1 times 3 is 3, and 1 times 2 is 1 times 20 is 20. Good. Now, do you guys remember learning the standard algorithm before? Good. Now we can move on. We put a 0 here. Do we ever put an x there, or do we always put a 0 there? We always put a 0 because now we're working with the tens. We're going to multiply 30. 30 times 3 is 90, right? And then 30 times 20 is 600. So our partial product here is 690, right? Then when we do standard algorithm, then we add the different parts, right? So let's add the ones. 3 plus 0 is 3. 20 plus 90 is 110. We can bring the 10 over there. 100 plus 600 is 700. So I want you to take a look now at the area model and the standard algorithm that you've written down. Where do the numbers, where is there any sort of relationship or overlap? Talk to your table group. Go. Let's draw some arrows to show which numbers are the same, okay? So we can see in the area model, here we have 23, and here's 23. So draw an arrow to connect your 23 to your other 23. You may not use the restroom right now because we are in the middle of a math lesson. Did you go during recess? Because we've been in from recess for only 20 minutes. Did you go during recess? Now draw another arrow showing that this partial product is right here, right? Finally, we can draw another arrow showing that our total product is right there. Do you guys see how the area model and the standard algorithm have all the exact same parts? Yeah. Great.